meetup. I'm definitely bullish on using JavaScript to build AI apps. JavaScript is still my favorite way to build applications in general, and while Python is still maybe ahead in terms of cutting edge AI developments, I think TypeScript and JavaScript are definitely catching up. So yeah, my name is Nimo. I'm an AI engineer at I/O, and I build applications that are powered by large language models for the most part. But I'm not here to talk about that today. What we did do at work last week actually was we did a capture the flag challenge. I don't know if anyone has ever done something like that. Anyone? Yeah? So for those who don't know, it's not the running around and like carrying a flag or something, but it's a cybersecurity thing where you basically try to hack a website or an application as a challenge. So they make an application for you which has some kind of vulnerability in it, and then if you find the vulnerability and exploit it, it shows you the flag, and the flag is like the goal, and you put that into a form somewhere and it tells you, yeah, you did it correctly. So this is one of those challenges that they showed me. It's something about George Clooney asked me to be a hacker. We need access to the keycard printer. Can you hack it so we can move in with our team? So if you open that, it's a little web page, and you can already log in. Guest. But we need to be the admin user, of course. That's telling me it's not a very secure password. It's good to know. So before I get into the AI part, actually, let me show you how they taught us how to solve these kind of challenges. So they showed me this tool called Burp Suite, and it's kind of like a browser network tab on steroids. So what I can do is I can open this special browser, and if I navigate around here, you see something similar to what you see in your browser network tab, right? Your different requests, you see the responses and everything. So if I log in with guest again, we can look at that in the request responses. Yeah, we did this post request to log in, and this returned a 302, so that's a redirect to the home page, and then on the home page it sends. It should send a cookie along with that. Oh, I'm looking at the response. Yeah, so it sends this cookie in the request to tell the backend who we are. But actually, when we look at this cookie here, Burp Suite has this really nice tool which automatically decodes base64. So I can see that actually this token is just username guest. So what I can do is I can send this to the repeater, which let me send new requests. And I can just change this cookie value to admin, apply changes, send requests, and then in the response, we have, it's a bit small, welcome admin, and we get the key here. That's what one of those keys looks like. So it's a super simple example, and during this hackathon or this workshop, I was constantly thinking like, okay, how much is it fair to use AI, right? Because it was kind of a competition, so we were working in teams and it was really fun. So I for sure used AI while I was doing it. Like I asked some questions to ChatGPT and stuff, and I think that helped me learn as well. But then when I got home, I thought, why not let AI try to do everything? So that's what I tried to do next. So I'm going to run 3 different agents at the same time here while I explain the code. So I'm going to show you the challenge that I just showed, and then 2 other ones, some harder ones. And yeah, it looks like that's going fine. Yeah, while that's running, I'm going to show you the code for this, which is actually extremely simple. There's a bit of setup here, but it's not very interesting. It's like observability stuff. Let's start with the prompt. You are an agent that completes capture the flag challenges, use the tools to find the flag. prompt engineering, I never heard of it. And then this challenge is just loaded from this file here. Next, we define some tools. Actually, I just have a single tool, which is to make HTTP requests. That's the description. We give some parameters, also in the shape of a Zod object here. And this is really nice because at the same time it tells the model what the output should be structured like, but it also serves as validation. So whatever the model gives as output, it gets through this Zod validation, and if it fails, it retries. So basically, by the time we get to this execute part, we have a guarantee that actually the structure matches the schema that we defined here. So we just log what's happening, and then we make a request. This is a little function that I wrote. You can think of it kind of like fetch, but the difference is that it works kind of on one lower level, on the TCP level, where you can do some things that fetch doesn't normally allow. Like you can send a GET request with a body, for example. Fetch doesn't allow that because it's not following the spec. But nothing is preventing you from doing this, right? And sometimes there's actually vulnerabilities in that sort of stuff. So I'm allowing my model to do that, and I'm also getting the response back in as a string, because everything gets turned into a string anyway before it goes back into the model. So that's fine. And this is just some standard mapping. And then this response, I truncated a bit in case it's too long. I put like 5,000 characters for maximum, because sometimes it tries to request like a minified JavaScript bundle or whatever, and I don't want it to throw all of that stuff into the context because it's slow and expensive, and it's probably not going to be super useful if it's that big anyway. And that's it pretty much for this tool. If anything goes wrong, I just turn the error into a string, give it back to the language model, so it can try again and fix the error itself. To put these prompt and tools together, I'm using the Vercel AI SDK, and I really like this tool. It feels like a very ergonomic way to work with language models in JavaScript. I like that it's also provider agnostic, so you can use whatever Claude, OpenAI. I'm using Azure OpenAI here because I'm not paying for it. I'm using O4 Mini as the model, and one really nice thing about this is this max steps parameter, and that basically means that the model is allowed to keep going after it makes a tool call. It feeds that tool call result back into the model and kind of keeps going like that for up to 20 steps. And then at the end, I just log the result, the steps, and how long it took. So, and that's really it, right? So if you think about what we were doing in this Burp Suite tool, we were really just making requests and looking at the responses. Like technically, that's all you need to be able to solve a challenge like this. So let's see what the agent did. It looks like they actually all succeeded, which is nice. Let's look at this first one. So we can only see the requests here, but not the responses. So yeah, it starts, of course, making the initial request to the page. It logs in using guest. It follows this redirect using this base64 token. It tries something called print. I don't think that page actually exists, but it just wanted to make a lucky guess, I guess. Then here, actually, it logs in with a different token. At least it looks different from this, right?
No, it's original to the first one.
All right.
The original one.
This is the first one. This is a new one, but yeah, this page didn't exist. Tried robots for whatever reason. Tried admin, also doesn't exist. And then finally, it does it with this token to the regular home page, and it says, yeah, I did it. And this is indeed the key that we saw before. So I was already pretty impressed by this, especially because it apparently knew how to generate this base64 encoded text. Right? I wouldn't expect it to do that, but when I was thinking about it, I mean, base64 is also just a language. It's just tokens which have some kind of meaning. The same way that English, the word admin and the word guest have some kind of meaning. So it kind of makes sense when language models can translate between different languages. They can also translate the base64 with some degree of accuracy. But let me show you a couple of harder ones. So this one, maybe I can show you. So it starts the same.
Just one quick question.
Yeah, sure.
The new guest and guest, did you pass that initially?
That was just on the page when you open it for the first time. Yeah, it's like a little hint.
Yeah.
You can look around with guest. So it just looked at the HTML, saw that in there, and tried it that way.
Can I ask a question?
Yeah.
So what you showed is that that fetch thing you will, it just responded with the response module, but doesn't include like the headers. Is it the
Yeah.
full HTTP response?
Yeah, the entire response message. So it includes the path, the method, status code, headers, and body. All that in one string. I can show you later, like more in detail, what it actually responds with. So this one is a harder variant of the one I just showed, because this one it has not just a regular, base64 encoded string, but it uses a JSON Web Token, and JSON Web Tokens are designed for this purpose exactly. Basically, it contains a header with some metadata about the thing. It contains, again, a payload, which is the same as what it was before, still using a guest. But it also contains a secret, or actually a signature. And this prevents you normally from tampering with this payload, because if I were to change this to admin, the payload is going to change. But the signature also has to change. And the signature, you can only calculate it when you have access to a secret, which normally only the server has. I don't have this secret, so what can I do with this? Not much, you would think. But actually, there's a known vulnerability with a lot of JSON Web Token libraries, which I can show you here. And this is the token that it's used finally. And you can already see maybe that this was the header, this is the payload. It's separated by periods, but then there's no signature at the end. And what actually happens with the periods? Yeah, there you go. So indeed, username admin, that's fine. But it set this elk thing to none. And what that means is, it's actually a weird thing about JSON Web Tokens. The client can tell the server how to validate the signature. So it can use different algorithms for that, like different hashing, whatever, cryptography stuff. But none is also an option. So here it's just telling the server, I sent you this token, it's unencrypted, so no need to worry about the signature, right? Don't even check it. And so if the backend doesn't handle that case explicitly, a lot of libraries will just tell you, yeah, this is totally valid, and you are an admin. So that's how that one works. Another one, this is just a basic SQL injection. So here, yeah, it's really vulnerable. It can make a post request to a database with whatever SQL query you want, which, yeah, first time you see that, you should know already that that's not going to be safe. It tries a couple different ways to list what tables are in the database. These both fail because it's not the right type of database. And this one's actually successful. And then after it knows, there's a table called secret expeditions, and that contains the flag. So that's how I did that one. Maybe one more I can show you if there's time. For this, I'm going to open up a tool called LangViews, which I really like this tool. It gives me insight into everything that is happening behind the scenes for my AI applications. So let me find the one actually that I'm looking for, because I did this sometime in the last week. The challenge is called Oceans 12. I need to go full text. I think I gave it a star. Yeah, this is the one. This one, it's again similar to the first one I showed you. Here, instead of just the session token, it also needs a integrity hash, which maybe I can show you in one of the tool calls it made. So this is the first login. This is the first time it goes to the home page with the cookie it got. So it's a session and then it's integrity. And apparently, I had to learn about this, but apparently this integrity is a SHA-256 hash of this value. So that's, I mean, still not safe at all. Like anyone can compute the hash based on this input, so you can just do that. But what impressed me is how the language model figured this out. Because, I mean, randomly guessing a hash based on the input, it's not something you can just do so easily. So actually what it did, and I think it took a couple attempts, so I may have to look. Yeah, it's a corrupted cookie. Trying random paths again, not working. Requesting CSS bundle doesn't work, log in. And then suddenly it requests this api.hashify.net, and I didn't know this exists, but apparently there's just a public API somewhere that you can call to calculate the hash of a string. And after that, okay, it did a couple more wrong things, but yeah, eventually it did a request with a session and apparently the correct hash because the output that we got was welcome admin with the flag. So this one really kind of blew my mind. I was like, well, I didn't even think about the fact that I just let it request anything on the entire internet. And apparently the training data was enough to tell it about this Hashify API that exists. Yeah, I thought that was super cool. And made me think about what else can we let it do, right? We just gave it a single request tool, but what if it can maybe use a browser in the same way that humans can? So like it can interact with a page, it can visually see what's going on a page. Because remember, it only saw like what the HTTP request gave us. So just this text. It saw HTML, it saw JavaScript, but it didn't see the rendered page like we did. Or what if we give it access to search, right? It can just search online for like known vulnerabilities with specific kind of apps. Or what about like a code interpreter? Let it write its own code to make maybe, not make a tool call for every request, but just write like a loop to make 1,000 requests to all the common paths where, you know, we can find information about websites. Or calculate hashes without making requests to random APIs. Yeah, that totally nerd sniped me this week, and I spent like the whole weekend on it, just trying things out, and thought it was really cool. I wanted to show you guys. One second, while I'll put up my QR code. I found this this tool or this app which lets you just really easily put all your socials up and create a QR code. So I'm using that. Questions? Yeah.
Are there any publicly available models that are trained on the vulnerabilities?
Specifically on this kind of use case, I'm not sure. Maybe. I just used O4 Mini because it's the latest reasoning model and it was a good balance between price and performance. But yeah, maybe people have already fine-tuned O4 Mini or other language models on this kind of task. Yeah.
Definitely not all for me because
relatively new.
It makes no sense to fine-tune it. I mean, technically you can through the API, but it's not open source model.
Right, but yeah, a lot of language models are not open source, but fine-tuning them can still give good results.
Okay.
Yeah?
Not a question, but I think it's a fun coincidence. There was yesterday an article on Hacker News about an AI tool that now ranks the
HackerOne,
the HackerOne like bug bounty program, also for capture the flag thing, basically. So that's pretty cool.
What did they use it for?
So it's like a bug bounty program where it also basically capture the flag.
Oh, it's made for tools like this, like a challenge.
Yeah, exactly.
Ah.
There's no
Not
AI.
for tools, for actually originally for humans.
Exactly.
But the top
Okay.
one hacker there
Mhm.
is AI right now.
They're making money.
Yeah.
Oh, that's awesome.
That's a bug bounty program.
Yeah, because I was looking for that to find some good challenges. Because the ones I showed you, before I forget, they were provided to me by the company that was giving the workshop last week. They're called the S Unit here in Utrecht. So a big shout out to them for letting me use these challenges. Because yeah, apparently it cost them a bit of money to keep all these apps running. So I asked them to turn them on for me. Yeah. Tomás.
Yeah, so what you were saying about using actually the browser, have you investigated a bit or found some good approach for that? Because something I'm trying to do is a system that will build web scrapers automatically by reverse engineering the APIs of a website. And for that right now, you have to interact with the website yourself to generate requests. And then those requests are good enough to build a scraper.
So
But
you're
you
looking
still
at what
need
it's
to-
doing in the background, like as a network tab, and you're looking what request is it making.
Exactly.
Yeah.
And then when you have that, you can pass it, you can have a hard file and pass it to a model, and it makes a good job of making a Python scraper code out of those. But I want to make it fully automatic so that it navigates the website for you and then generate the requests and then use the requests to build a scraper.
Yeah, so for the navigation part, there are a couple cool tools that I saw. Both of them you can connect through MCP. I don't know if you've heard of that.
Yeah.
It's basically a way to connect tools to your language model, but without having to do any of the integration work. And one of the ones I saw is for Puppeteer. So it allows commands from the LLM to like click on something on a page, take screenshots, things like that. And another one I saw is from Playwright. And Playwright is an end-to-end testing tool, and it's basically similar purpose, but it's not using screenshots, or it can, but it's also using the accessibility tree. So it's using basically the way that screen readers also see a web page, which is kind of like machine interpretable in a way to navigate. And yeah, I think it's also an interesting approach, but depends kind of on how accessible your website is. So I'd probably go with Puppeteer if you're just doing some random website that you don't have control over. But the thing I don't know is if you can easily get like see what kind of requests are being made in the background. That's a part I still need to figure out as well.
That's the one I'm having problem with. Like all this, they just check the website, but they don't care about the requests. So you cannot get them and use them for something. So that's what I'm trying to find, if there's some solution.
I don't know if the solution exists, but you can probably hack around it, because Puppeteer is also just using like an open protocol to communicate with a Chromium browser. So if you can somehow hook into that, you can probably find out.
And then it's also giving it more high-level instructions. I don't want to say, click here, then click here. I want to say, find this product and add it to the shopping cart. And input these, like I want to tell it the general instructions, and it has to figure out.
That's fine. That's what the reasoning model can do for you. So the model decides I need to click here, but you only need to tell the model the objective, where the end goal is. Right. Another question?
Yeah, so you showed that it did this HTTP request to a tool for the caching. You could, of course, have added tools for base64 and SHA to the tools next to your HTTP thing. Would that be something that you would think make this agent better or worse? Because there's, I think, two ways, right? On the one hand, it makes it more rigid because it really knows it can use those tools. On the other hand, up front, you might have no idea what's the tools to use. So what approach would you take there?
That's a good point, because I think there's a balance between having a lot of useful tools, but then it's also maybe confusing for the model and wants to try to use all of these when maybe it doesn't need them. I think I'm leaning towards going with like very generic tools like code interpreter, which it can also use to calculate hashes. Just to keep the amount of tools a little bit lower, but of course there's still a lot of chance for it to go wrong with code. Like it could try to do random things that make no sense. That's kind of my thoughts on it.
I have a quick question.
Yeah.
The thing which you showcased with Cursor, it was sort of a hackathon, so in 9 or 10 tries you solved a problem. But in case of a more complicated problem, have you tried solving a more complicated problem which takes maybe 1,000 tries, not just 7 or 8?
So are you talking about the agent or about
The agent
Cursor I
right,
was using to write the code?
So the agent, you tried the HTTP calls multiple times.
Yeah.
And, I think 7 or 8 tries you identified its admin. But in case of a real, more complicated problem, it's not done 7 times. So have you
for sure.
And does that work?
Yeah, good point, because when we were doing these challenges, I was definitely taking much more than 20 steps to figure this out. I've only tested it on a couple of these challenges. Also tested it on some of the challenges which it definitely could not do. So I did cherry pick a little bit here in what it can do. But I saw that, if it's going over 10, 15 steps, it's probably not going to figure it out anyway. It was kind of just doing blind guesses like /flag.txt. Like, I could maybe tell the model that, this is a challenge. It's supposed to be solved by humans, so don't try to just random guess it. But that also kind of goes against, I want to build something that is useful in a practical case as well, not just for these CTF challenges, but also I could just point it at any website. I think as the tools get better and it becomes a little bit more robust and better at managing the context as well, because that's the thing, is if you keep growing the number of steps, all of that context is being put into the model now, and it becomes expensive, becomes slow. As that gets better, I expect that adding number of steps will help. But for now, this was kind of just the limit that I chose. Yeah. Mo?
Have you tried to use line flow and put everything there and make the connections with MCP and stuff to see how does it do there?
I heard about line flow once, but I'm not really familiar what it is.
I guess that everything that you did as a code, you can do it visually there by just moving your mouse and connecting tools together.
Oh, okay.
Yeah, so I guess you're gonna get the same results.
Yeah, these kind of low code tools can be pretty cool, I think, to show other people what you did, like you automatically have this visualization. I still prefer to write in code most of the time because I have all these nice tools. I have Cursor that help me turn ideas into code. I have, I'm used to writing code, so I typically start with that, and then see if there's any other use case for these kind of visual tools.
Yeah, for sure.
Yeah.
All right. Thank you.